This is Maciek from OpenCashew. Dagobert Michelsen is joining me today to talk about buildfarm setup. OpenCashew is a package building project, and the buildfarm is the most important piece of infrastructure that we have. This is where we build all the packages that we release. We've been working on making it easier for people to set up their own build farms. So maybe let's first talk about why you might want an own build farm. And if not a complete build farm, then at least a build host. I've shown how to set up a basic build host on one of the previous videos. But if you want to build for both Spark and Intel architectures, and potentially for both Solaris 9 and Solaris 10, there are additional things you can do to make packaging easy and consistent. So, yeah, why would you want a build farm? What does it mean, easy and consistent in building packages?
Yeah, the main reason to do so is to make a special environment where you control which packages are installed, to have a defined base to depend upon. For example, if you want to compile against a specific set of libraries, you of course want to make sure that these packages are actually installed on the machine. When you set up a specific machine for building, it is best to do so because the setting up of the machine has some requirements which are needed, which a normal machine may not have. For example, you need to install a compiler, you install lots of development packages, you want to make sure that you have a complete Solaris system with all headers installed and things. So when you have a complete build farm made out of several different build hosts, it allows you to make packages for a wide variety of operating systems and architectures. For example, you could do packages for Solaris 9 and Solaris 10 for both Spark and Intel, and build these packages more or less automatically with one recipe. So you can just issue mgar package or mgar platforms and be done with it, and the build system automatically hops over to the specific machines and builds everything and assembles the packages.
So I can guess that this requires some sort of special setup. The hosts have to know about each other to be able to accept, I don't know, a build request from the host on which you're logged in, because you're logged into one host, but you're accessing all of them if you want to build everything in one go.
Sure. You usually build the software with a specific account, different from root. That means you have some kind of Cashew build user or something. And this user needs to be configured to have a shared home directory on all the build hosts. Usually this is implemented via NFS sharing, but you could also have some kind of cluster file system if you want to. And in addition to that, you need passwordless SSH to have been set up. That means if you hop from one host to another via SSH, it must work without password invocation. Theoretically, you could use the hopping over with passwords, but it's usually too cumbersome to enter it 10 times in a row when building stuff. But basically, that's it.
You can probably set up also a like some sort of a SSH keys with SSH agents that will allow you to do that without a password, but you will not have passwordless keys, right?
Yes, sure. Sure, of course. Absolutely.
Cool. So you said that you can just issue one command and build everything. So everything means what? You have, how many packages do you get?
That depends on how you configure your setup. The main line for OpenCashew, that means for our official packages, is at the moment Solaris 10 only for Spark and x86. That means for each software you package up, you get at least 2 packages. Unless it's architecture neutral, then of course you just need one of that. If the software is being split, for example, in a library package and a development package, it's a matrix. That means 2 packages times 2 architectures, resulting in 4 packages. If you configure your build farm to also have a Solaris 9 build hosts, and you require different builds for Solaris 9 and 10, Spark and x86, development and library, you would end up with 8 packages.
Mm-hmm, mm-hmm. So maybe a word about dependencies. I remember that we have decided to not depend on SunW packages, and I think this was one of the reasons that we used to build for 9 and 10, and they were not consistent, right? You couldn't set that I'm going to depend on SunW blah, because SunW blah could be named differently on Solaris 10 and differently on Solaris 9.
Yes, so the main reason was not really that we have different packages for Solaris 9 and 10, but that we had the same package for Solaris 9 and 10 built on Solaris 9. So if you build a package on Solaris 9 depending on a Solaris 9 SunW package, that package is most certainly named differently on Solaris 10.
For some time, we were able to get by without something like MGAR platforms. I mean, for now, right now, it's hard for me to imagine to live without it, but we did live without it for some time. And it was just basically because we built one package that we installed on both 9 and 10. But these days, we are building quite often separately for 9 and 10, or sometimes just for 10.
Yes. Most notably, these packages are the ones that access kernel data structures which require this. One of these packages is LSOF.
Oh, because it depends on the kernel, doesn't it?
Yes, and it needs to access kernel memory structures, and the binary needs to be specifically tailored for that. A build host is a machine that is used for building one modulation. If you remember our talk about modulations and merging, you may remember that during the build, several modulations may be used, for example, to build one 32-bit version and a 64-bit version. And
right.
The build host is selected per ISAR. Usually in Solaris 10 times, you build every ISAR on the same host. That means if you have one Solaris 10 Spark host, you build every modulation on that host. If you have a Solaris 10 AMD 64 host, you build everything on that host. In earlier times, however, this was done differently. When you said that we had combined packages for Solaris 10 only, when you said earlier that we had packages built on Solaris 9 only, which could then be used on Solaris 10, we had a special setup for Solaris 9 x86 packages, which also included 64-bit versions. And as Solaris 9 does not have 64-bit at all, this modulation needed to be built on Solaris 10. So the Solaris 9 x86 package was in fact a combined package, which was partly built on Solaris 9 and Solaris 10. So
I see.
In this case, you needed to hop over between two different hosts, even for one package. Yeah, so that's basically a build host used for building.
Mm-hmm. So building could mean compiling. It's more than just compiling, but basically compiling and linking the binaries. That's what a build host is doing.
Yeah, basically everything that is used inside a modulation.
Right.
Unpacking, patching, calling configure, build, test, install, and merge. This is done on the build host.
Right. So what is the packaging host then? The
packaging host is the host that actually assembles the package. That means after all modulations have been merged, we have one unified tree below package root, which contains all files to be put in all packages generated by this recipe. And the packaging host is the host that actually grabs these files and puts them in the different packages and spits out the packages to be released.
Okay, sure. So you have one unified tree structure in the directory structure that holds all the files that will be later divided into packages. Yes, we did talk about this in the previous talk about modulations. Right. So let's talk about usage. So if I have let's say a Spark box and a Intel box, and I'm sharing the file system between them. I have a user. I'm able to do passwordless SSH in between them. I assume that the hosts have to somehow know about each other. Like for instance, if I say like Memgar platforms build everything, it has to know that I'm going to build for what, Solaris 10 Spark and Solaris 10 Intel. So it has to know where to SSH.
Yes, the first thing which needs to be known is on which platforms the package is actually to be built. This is defined in the gar variable packaging_platforms, and the default value at the current moment is Solaris 10 minus Spark and Solaris 10 minus i386.
So there's a default value, but you can also override it in your recipe.
Sure, you can add any packaging platforms and packaging platform names as you want. The only thing you need to do is you need a mapping on how to match these packaging platform hosts to real host names. And the usual place to put this is in etc opt cashew gar rc, or you could also put this in your local tilde.gar rc. But yeah, the global configuration is the most casual one.
Okay.
So we may have a look at the configuration window.
Mm-hmm.
Okay, so we are now at the login zone, and I'm now hopping over to the gar configuration. So we first see the configuration default. I have all these files in, I am now at the login host, which is this position where you enter the build farm, and from here you can hop over to the different build hosts. I will first show you the default configuration where the packaging platforms is defined, and for me this is at mgar gar v2 at gar.conf, and in here you see the packaging platforms. There you go, below here, Solaris 10 Spark and Solaris 10 i386. But you could change this and override it, for example, in your gar rc or even in your package makefile, that it's built for more platforms.
I still don't see
now,
it.
Pardon?
I still don't see. Okay, I see it now. Yes. Okay, so this is the packaging platforms, and question mark equals means what?
That means it is defined. It is defined in this default configuration if it does not already have a value. So if you define packaging platforms in your recipe makefile, it won't override it. So it's only set if it's not already defined. Yes. So Solaris 10 Spark and Solaris 10 i386 are now abstract values, and we have to map these on specific hosts. And this is done by hopping over, for example, to unstable 10s, for example. This is a Spark build host, and now we look at etc opt cashew gar rc, and we see here that we have several, we need to go down a bit, we now see different packaging hosts. Packaging host underscore is the prefix you need to have, and the value after that, for example here, whoops, that's not what I wanted, this here is the name of the packaging platform. And this is now mapped to the specific host name. So unstable 10s is a host name for me, as is unstable 10x. So you can make here arbitrary assignments between packaging platforms and host names. Here.
Cool.
So this is for packaging. And there's a similar mechanism for building, for the build hosts. And as I said earlier, the build host is defined by the modulation. And what I do here is that GAR calls a function, in fact, the function modulation to host. And you can use any variable which is available in GAR and then result in a host name. So if you have some arbitrary complex modulation with 10 modulators, you could all use this to hop over to a ton of machines and make some kind of weird hybrid package if it would be required. We are using at our build farm only the GAR platform, which is exactly what we have defined here. These are the platform names. And we use the memory model of the specific ISA. That means, is it 32-bit or 64-bit?
Okay, cool. So when that is set up, so the build system knows where to SSH to when it wants to build for a specific Solaris version and architecture. What's the usage? What kind of commands do you issue? For instance, what if you want to build all the packages, and let's say what to do if you want to redo parts of your work? For instance, you've built your packages, but you want to change something, so you've changed the recipe, and what do you do then?
You would usually clean up everything you have. If you change some part which is for example, redoing the configure phase. That means doing spotless, which removes everything, and then you would do mgar platforms, and that would generate all packages on all platforms again.
What is spotless? Spotless is a mgar target, so you say mgar space spotless?
Yes, spotless is a specific target which removes basically everything which is volatile.
And what if I were unsure about what spotless does? How can I check what is it actually doing?
If you're unsure what a specific target does or anything, you could always just look into the mgar system. We can hop over to mgar gar v2, and if we don't know what spotless does, we can just grab there, say grab spotless, and we see here that gar mk has a rule which maps spotless to image clean. So we go into gar mk, search for spotless, and see that it's removing work old, then moving work to work old, and then removing work old in the background. Basically that means remove the working directory and do not wait until it's done.
Cool. Yeah, that's handy, because I think that removing a large build can take time, so you might not want to be tied up by just RM finishing. Cool. Is there anything else we want to show?
If you want to know more about how platforms actually work, or if you just want to read the write-up, you can go over to gar opencacheu.org, as always, and then move down, as always, to the advanced GAR topics, which is most of the time what we are actually talking about. And then you have the platform sections right in the middle of the page. And in here is a full explanation, what is the platform stuff all about, where are packages assembled, and how modulations work, and what you need to actually set this up. Yeah, if you have any questions, any feedback, just let us know. Drop us a note on #OpenCashew on IRC. Send us a tweet.
On IRC on Freenode.
Yes.
That's where we are. Okay, cool. So that's all for this video. Thanks for watching. If you want to know more about OpenCashew, our website is at www.opencsw.org. You can also follow us on Twitter and on Google+ and Facebook. Bye!